So welcome to my talk, typing your Python code like a ninja. I think like it's very obvious what I'm going to talk about. And like starting with about me, so my name is Thiago Bellini Ribeiro. I'm not Italian, I'm actually Brazilian. I have some Italian roots. I'm living currently in the Netherlands where I work. I am also an open source maintainer. I am one of the maintainers of the Strawberry GraphQL library. If you ever have used it, I am one of the devs behind it. And yeah, as I said, I'm working in the Netherlands. I work as a software engineer for the St. Cloud, the company. And I'm a great beer enjoyer. So let's get started. I'm not going to go too much into the basics. I think we are all familiarized with the basics nowadays. But let's just start with a basic example in here. So very simple example. We have a double function, takes an int, makes it times 2, and returns an int get user, takes a primary key, returns the user. So far, so good, right? We can try to extend it to make it so double can actually work with strings as well. Like we can multiply a string. Get user, we can modify it to like make it strict or not. So if the user doesn't exist and it's not strict, we return none. Otherwise, we raise an error. So that means that we can either get a user or none here. And if we try to use it, you can see that if I try to pass like double, I try to pass 10. When I reveal the type, it's a string or int. The same for the user. If I try to do even the strict, I know that I'm always going to get a user. Otherwise, there would be an error. But I still like need to narrow this after because it can be known on the typing. So yeah, that's not bad, but that's not good as well. So how would a ninja solve this? So that's where I introduce overload. And overloads are basically just that. So you have multiple signatures of that same function. Like some other languages actually implement overload in other ways. Python has a single implementation, which is like where you actually define the code, but you can define other signatures. So in this case, the double, when you pass an int to it, you are going to get an int back. If you pass a string, you get a string back. And this is the actual implementation. So, yay, now if I pass 10, I get an int. If I pass foo, I get a string back. It's going to be foo. And typing is happy now. That's pretty good, I think. The same for the get user. So I can now tell this is like a little bit more complex, but not that much. So if I pass literally true to the strict, I get a user. If I don't get one, that means an error happened. If I don't pass, and also the default is false, I can get a user or none. And then I can have this. I can do a get user. A get user without strict is going to give me user or none. But if I pass strict, now I am sure that I get a user. I don't need to check, oh, is this none or not? And if I don't get it, I want it to fail. I don't want to have like silent errors. But some of you might have noticed it. There is a way to improve double even further. So that's where I introduce generics. Double, if you have noticed, like it can work with other stuff as well, not only ints or strings. It can work with a decimal. So if I say that I can take a generic typing here, and I'm going to return the same typing here, now I can pass 10, it's an int. When I pass foo, it's a string. When I pass decimal, I get a decimal back. So yeah, that is like we have a lot of power now. But and of course, if you are using Python, I think it's 3.13 that introduced this new syntax. I'm sorry, I don't remember correctly, but you don't need to import type var anymore. You can just do this. It's syntactic sugar, but I like it. I think it's cleaner. This way, you say that this function will use a generic t. You say that x receives t and returns the type t as well. Suppose that we still don't want that kind of power to be used. We want to limit it to only strings and ints. So we can define an upper boundary of the type. In this case, t is limited to strings or integers or subclasses of those, not many subclasses of those, but still, you are still going to get the generic working the same way. But now, because of the upper boundary, if you try to use a decimal, for example, the typing will not allow. This is not a runtime issue, but the typing, for some reason, maybe you don't want to have decimal. It's fine, like it's your program. Generics can also be used for classes. So very simple implementation of like a model manager. Suppose that we have a model manager here. This is a generic class. T, in this case, can be a model or a subclass of it. And the init takes a model class, which I store, and then I have a function, which when I call it with a primary key, I get back an instance of T. So if I try to instantiate this, I'm going to get a model manager of user. User, in this case, is a subclass of model. I get a model manager of user, just like a list of an integer. I would get like a list is a generic container. And if I now want to do a get for in this user manager for the primary key, I got the user back because that is what my function is returning. And we can also have generic callables. Like this is, I think, probably the most complex one that I'm going to show, but like it is actually pretty simple. If you take a look, like ignore for now like the arguments, you have a timing function which takes a function here and returns another function. That's basically it. So the function that it's going to be returning is this inner function, which takes whatever arguments and keywords, and literally prints the time it took to run that function and returns. So it's like it's a decorator pattern, and we can use it like this. So, but without the typing stuff here, by adding timing to complex func, we would lose all the typing information from the original function in here. By capturing the parameters in here and the response value, we say that we receive a function, a callable, with parameters p and response r, and we also return another callable with parameters p and response r. We can manipulate this, use concat to like add extra parameters, do injections. Not going to go through this right now. Like we could have a whole talk about generics only. So yeah. So moving on to another problem now. So let's talk about type narrowing. So another very simple example. We have model and a user which inherits from model. We have a function called process user and a function called process object. Process user takes a user. Process object is generic, and in case it identifies that the object is a user, and this function is doing the check, it's going to call process user. Runtime, great, but can you spot the issue with the typing here? The issue is basically, is user, okay, for is user, when you do is instance, you are narrowing, but in here, the type checkers have no idea that you just narrowed it to be a user. So for the type checker, this is still a model. And if you try to pass a model to process user, it doesn't work because it wants a user. So it's Ninja time again. So let's introduce now type guard and type piece. So that's the whole reason why type guard exists. This is a very simple example. Probably you would want to do like his instance directly, but maybe you have a more complex case to check if something is of a given type. And in this case, the type guard can be used as a return value to a function which returns a Boolean, true or false. And when we say that if is user of the object, this gets narrowed because of the type guard, this gets narrowed to user. So inside this, we know the type checker knows that this is a user. So we don't have typing errors anymore, like magic. And so you would think, oh yeah, so if I have the same function which takes a user or a ninja, if I do this, this is a user. And the else, this would be ninja, right? Of course, like at runtime it's actually ninja. But, well, that's not how type guard works, unfortunately. Like that is like there is a history behind it. There is a whole reason why. I'm not going to go into details, but that is where we have type is, got recently introduced in the language, which behaves the way that most people would expect that type guard should behave. And now the else is actually ninja. So like, I'm always going to say, like, if you want to use one or the other, usually you want type is. If you need type guard, you know that you need type guard for some specific reason. Moving on to another topic, so for the KWArgs lovers. Again, like, so let's now try to create a user instance. We define a function here, takes whatever, and calls user.objects.create, like this is Django, let's say, passing all the KWArgs. So far, so good, but let's say that username is the required attribute in there. If we do this, okay. If we forget to pass the username, we just pass the first name, runtime error, because, well, username is required. And, or if we do this, username is here, but age doesn't exist there, another error. But how can we protect ourselves against that? Because, well, KWArgs takes anything. The ninja appears once more, and that's when, like, we understand that we can use type dicts for this. So on a type dict, we can say, oh, those are the arguments that I take. Username, it's the required one. First name can be given as a string. Last name can be given as a string or none. And we unpack that, that typed dict into KWArgs. So now the typing is going to, if I do this, I even get code completions depending on the ID that you are using. If I do this, it's okay, but this is going to be an error because it's going to say, oh, you are missing passing username. If you do this, it's going to say, oh, we don't have an age. So the typing is going to actually help you with that. Of course, in this example, I was using total false, which means like you don't need to pass everything. Everything by default is not required unless you say that it's required. But you can remove this, which would make everything required, and you can use the other way around and do not required for the stuff that is not required. So lastly, let's talk about overrides. Okay. So overrides, this is something like most people don't understand exactly why it exists. It seems like just a fancy thing, but quick example here. So we have a person class. Suppose that this is even coming from a third-party library, which you don't have control over, and you create a ninja, which hopefully is a person. And you want to override how move2 works because, well, ninjas move very differently than normal people. So you do this, okay, great. And if you have a function that takes any person, you can make the person move to some place. Even if it is a ninja, this is going to work. But what happens if the person moves to signature gets changed this way? Again, that's why I said maybe this is coming from another place, because you wouldn't know unless you have a unit test for this. Otherwise, you're just going to get a runtime error in this case, because now you don't get X and Y anymore. Now you get a tuple of coordinates. So how can we protect ourselves against this runtime error if we pass Ninja? So the Ninja hits its final blow in this time, and we introduce override. So override is basically, I come here and say, well, when I'm defining move to, I am overriding something that already exists in one of my parents. So that will tell the type checker that, please let me know if I am actually overriding something. So if move to gets removed, it's going to say, oh, you are not overriding anything. Don't do that. Or if the signature gets changed in a way that it's incompatible now, it's going to also alert oh, this is incompatible, also don't do this. Type checkers are usually now doing this as well, but still override is nice because of if the move to gets removed, you want to know. So yeah, override is more than just a fancy decorator. At first I thought it was just a fancy decorator. So enough of ninjas now, let's talk about self. But what self? Myself? Yourself? No, typing self. Okay, it worked. Wasn't sure if it was going to work, but yeah, for that, let's make some pizza. And yeah, so let's make some Italian pizza here. So let's use a builder pattern for this. So to make an Italian pizza, we make dough, we add tomato sauce, we add cheese. I'm not adding everything here just to keep it simple, but if we call this pizza, we instantiate Italian pizza, make the dough, add tomato sauce, add cheese. What we get in the end? Italian pizza. And of course, Ernesto approved this. Who wouldn't? And now I have to give a warning here. Some viewers might find the following image very disturbing. So viewer discretion is advised, highly advised. Let's make now some Hawaiian pizza. And yeah, so what is the deal with the Hawaiian pizza? They will want to add pineapple. And when we try to make the Hawaiian pizza, it's still trying to be made like an Italian pizza. So it will still try to make the dough, add tomato sauce, add cheese, but try to add pineapple after. What is the issue here? If you notice it here, the make dough returns an Italian pizza. So when I do this, make dough, now this object is an Italian pizza. Add tomato sauce, okay, this is going to work. Italian pizza, you can add tomato sauce. Add cheese, it will work. You can add cheese to an Italian pizza. But you don't try to add pineapple to an Italian pizza. It's not going to work. Ernesto totally disapproves this. So, so how can we fix this? And that is where we introduce self, which, again, seems like just a fancy way to not repeat yourself with the class name. But if we change this, again, the whole implementation is not here, but I'm changing make dough to self, to return self, and also add pineapple to return self. And now, everything works the way it's supposed to be, still not great pizza, but at least it's not in the Italian one. And I don't have any images for Ernesto for this, but I guess he approves slightly. At least it's not in the Italian pizza, right? And fitting it almost, perfect. So fitting almost all together here, let's just a final example of almost everything that we did, we've learned it so far. We have a class Ninja here, which we have a method to move to some place, which can either receive a latitude, longitude, or a location instance. And this would be using the overload. Because we are ninjas, we can clone into another target, the target can be another person or another ninja. And what we get back is the clone of that target, whatever if it is a person, a ninja, or a subclass of one of those. Or we can even hide ourselves, we are ninjas, and we get like a hidden instance of ourselves. And that's all that I have for today, folks, and thank you very much. This QR code has, if you want to, it is to download this presentation. I think it's going to be available at, for yeah, it's going, right? So, but you can download it now if you want. And let's go to QA.
Thank you, Thiago. Thank you. So, this was a great rundown into slides, and you already have answered a question that came up, with, which was, please share the slides on Discord. There is an additional thing.
On Discord.
Copy and paste.
Okay, I'm going to. I'm going to.
Start typing other questions. I gotta get out of there. I mean, there are so many phones pointed at this thing. You'll get the typing. So there is another question. Somebody probably got convinced that the typing is good, so they're asking, are there good strategies to incrementally add typing to a code base?
Okay, that is a very good question. To be honest, I don't have a proper answer. I know that there are, like, if you are starting with a code base that is not typed at all, there are some type checkers that has like a baseline which you can use. For example, if you are using, let's say, Pywrite, you have a fork of Pywrite, which is based Pywrite, if I'm not mistaken the name, and they have a baseline which they create like a baseline file saying, oh, those are the existing issues. You can't introduce more than those, but during new development, you are going to be removing some of those, but so you can introduce those slowly. I know also Thai, which is like will be soon the new cool kid in town, like from Astral, type check and also language server. From what I've read, it's going to allow you to do incremental application as well. So yeah, I'm looking forward for Thai.
You keep answering questions before I give them to you, because Florian is asking, have you looked at Project Thai by Astral?
Oh yeah, I have. I tried. So far, like, it's pretty good. As you might imagine, it's blazing fast. But there is a lot of still like false positives. I tried using it as a language server in my IDE as well, and like it's missing a lot of stuff. You can't like go to definition. You can't hover. Hopefully, we'll have that soon. But again, like, I'm really hyped about it.
Okay. Now, a question about KW args, or is it quirks? I don't know. Why not just list them out in the func method, the definition? Oh
yeah, no, of course. Preferable, that's how you say it. I'm sorry, I don't know. But you want to do that. But there are cases where you need KW args for some reason, and when you do, that's when you can use typedict to help you at least have some sense in your KW args. But yeah, I would say, like, if you can add the options in there, do. It's better. Explicit is always better than implicit. Zen of Python.
Still on quirks, and it's Maxim Danilov that says that he thinks, sorry, but your example with Django create user does not work because on dev time quirks contexts are not known. Or am I wrong and unpack work on work time or runtime, I think? In this case, you get exception on the next line.
Not to be honest, it might not work. I literally created those slides like 2 days ago, and I'm doing the presentation full YOLO. I'm sorry if some code doesn't work. Let me know. I can like provide how to make it work. But yeah, it can be that it doesn't work.
The code example doesn't work, but it would not be feasible to do the quarks things on the create user by Django. Maxim? Okay, yeah.
We can discuss it simply later, and I show you why it's not working.
Okay, perfect. Again, I haven't paid full attention. You probably are correct.
Okay, now there's probably an inside joke because someone is asking you to tell us what is covariance.
It is.
Typing ninja.
Oh yeah, like a quick summary. Like if you have ever tried to use typevar, you probably encountered like the words covariance and contravariance. Not going to talk about this because it's actually very complicated stuff. But the basic is this: covariance is anything that when you have the type, just like I showed, if you have a user, you can pass a user or anything that is is a subclass of it. If it is contravariant and you have a ninja, you can pass a ninja or a user because a person, because the person is a superclass of the ninja. Why would you, contravariant is, I think, is the most complicated one. The use case is very niche, but again, not going to go into details because it's very complex. I could have a talk just to talk about generics in general.
Mm-hmm. Well, we have 3 minutes of time, so keep questions coming. There is another one who just popped up. What are your favorite arguments when discussing with typing skeptics developers?
So my main, I've had a lot of discussions with a lot of people that don't like typing. So one of my arguments is I was once a hater of typing as well. I was, as he said, like at the beginning. Back then, I have been a Python dev since 2010. Typing was not a thing back then. And when it got introduced, I was, if you want typing, go Java. Like, you should not do this in Python. It's not the Python way. But after a while, I started seeing some advantages. Like, for example, if you want unit tests to cover most of your code. But let's be honest, like you are never going to have 100% coverage. If you do, like your project is probably outdated already. So having a good typing in your code makes it so that if you do a change in a code that is not covered by unit tests, at least the type checkers are going to alert you that, oh, you just changed the type of this variable, now this will not work anymore. Again, the unit test would catch that. That is usually what I get back as a response. But I think it's clever to have it. And also developer experience. You get code completions, you get documentation in your IDE. So yeah, why not?
Okay. There's Stefano, who expresses a feeling with many of us as fault. Fantastic talk. You showed an argument being typed as literal false. Why not just false?
Oh, this one, right? Let me find it. Oh, it's at the very beginning. Is it? Where is it? Have any of you seen it? Earlier? Okay. Oh, okay, it's here. So the thing is, so literal means you are literally passing something that is inside literal. If the typing itself, I can't, there is no false. There is bool. But if I pass bool, it catches everything. So I'm saying if the overload and the order actually matters. So if someone calls get user and passes strict equals literally true, then this is the signature that I'm going to use. If it passes false, this could be bool as well, it would also work because I'm handling through here. So the only other possibility because of the ordering is false. But if I pass false, or if I don't pass anything and, okay, this is the default because equals false, then I get this signature. But you'll need literal because false itself is not type. False is an instance of the type bool.
Okay, we have just one time for a yes or no type of answer because we run out of time and then you can keep asking questions later. And this is, would you make typing mandatory?
Yes.
Ooh, spicy. Let's discuss with Thiago and thank him again.